Hello everyone, this is our 11th lecture, that means 2.11, and today's topic is alternating series. Okay, so what is alternating series? Alternating series, that means actually we have learned all the series was positive term series. Positive term series means each term of the series is positive. Now alternating series means here the sign of each term will be alternatively changed. For example, suppose I am writing 1 minus half plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6 plus dot 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 and so on. Okay, here you can see that the signs are alternately changed. First plus 2 minus, minus 2 plus 2 minus, minus 2 plus and so on. Okay, this type of series is called alternating series. Okay, so what will be the general form of alternating series? Suppose what we can write for this series, what we can write the general form for this series. This series is of the form 1 by n, 1 by n, but if I write only 1 by n, so it will represent the positive term series, but we need alternating series. Okay, so I am writing minus 1 to the power n. Okay, if I write summation minus 1 to the power n 1 by n, and n runs from 1 to infinity. Okay, n runs from 1 to infinity, minus 1 to the power n 1 by n. Is this expression is correct for this power series? Let's check. First, n equals to 1. N equals to 1 means minus 1 to the power 1. That means minus 1. Okay, now next one is n equals to 2, so minus 1 square, so this will be plus into half. N equals to 3, so minus 1 by 3 and so on. Okay, that means there is a difference between a sign, yes or no? Here first term is plus, but here first term is minus. Here second term is minus, here second term is plus. So we have to change this sign differences. That's why here I have written minus 1 to the power n. If I write minus 1 to the power n minus 1, n minus 1 or n plus 1, anything, then obviously it will change. Now minus 1 to the power n minus 1, if I put n equals to 1, so this will be minus 1 to the power 0, and anything power 0 means 1. So sign changed to plus, yes or no? Now if I put n equals to 2, so this will be minus 1 to the power 1, so minus into half. N equals to 3, that means minus 1 square, so this will be plus 1 by 3 and so on. Now you can say that this is the standard form of this series. Okay, that's why the general form of series is denoted by, general form is summation n equals to 1 to infinity a n, sorry, minus 1 to the power n minus 1 un. Okay, now I think it is clear that why this power is n minus 1. Clear? To make the first term positive sign. Okay, and this is the general form of alternating series. Okay, in positive term series we have calculated how to find out the series is convergent or divergent and so on. Obviously for alternating series we have some test, and most important and most powerful test is Leibniz test, which is included in your syllabus. Okay, so our next topic is Leibniz test. Okay, so you have to remember you can use Leibniz test only for alternating series. Apply it only for alternating series. Clear? we can apply Leibniz test only for alternating series. If you see that there is a change of sign, plus minus plus minus plus minus, so obviously a Leibniz test, and this is the only one test which is included in your syllabus for alternating series. Clear? So if the question is given plus minus interchange, plus minus change of signs, then no doubt you can use Leibniz test. So let's write the statement. The alternating series summation n equals to 1 to infinity minus 1 to the power n minus 1 un. You can write n plus 1 also. Converges if, number one, we have two conditions. Number one is the sequence un. The sequence un is monotonic decreasing. Okay, the sequence un will be monotonic decreasing. Number two is limit n tends to infinity un, this is equals to 0. Acha, first, what is, actually you know what is sequence. Sequence means arrangement of the numbers un. Okay, here you can focus that this is mentioned only sequence un, sign is not mentioned. Okay, sign is not important here. Sign is given only to show you that the change of the sign, nothing else. Our main part is this un, or you can say this 1 by n. We have to calculate the whole problem using this 1 by n. Clear? Or using this un. So first one, the sequence will be monotonic decreasing. That means if you increase the value of n, the value of un will be decreased. Okay, now the limit of un, here un means nth term of the series, so the limit of un will be 0. Okay, if any series or if any alternating series satisfy these two conditions, then we can say that the alternating series is convergent. Clear? If any one of the two conditions does not satisfy, then we can say that the series is divergent. No, we cannot use the word divergent for alternating series. We have to use oscillatory. oscillatory. Okay, if any one of the two conditions does not satisfy, then we can say that the alternating series is oscillatory. We cannot use the word divergent. Clear? For alternating series we cannot use the word divergent. So let's start. Now problem is how to show that a sequence un is monotonic decreasing. How to show? Actually monotonic decreasing matlab the next term will be less than the previous term. Yes or no? The next term will be less than the previous term. That means you can say that u2, this is less than u1, second term is less than first term. Similarly you can say u3 is less than u2. Similarly you can say u4 is less than u3, and so on. That means you are getting the relation like this: u1 less than u2 less than u3 less than u4 less than u5, and so on, dot dot dot, uk less than uk plus 1 for any arbitrary value of k. Yes or no? For any arbitrary value of k. Clear? So we can say that un that will be greater than the next number un plus 1. Yes or no? Un plus 1 will be less than un. That means the difference un minus un plus 1 the difference un minus un plus 1 must be greater than 0. So if I can show you that the difference between the two numbers un and un plus 1 is positive, then we can show that this is monotone decreasing. M dot D means monotone decreasing. Clear? So first we have to show that this un minus un plus 1, this is greater than 0, then we can say that this is monotone decreasing. Second, we have to show that the limit n tends to infinity un, this is equals to 0. If these two conditions hold, then according to Leibniz test, the series will be convergent. So let's solve using an example. Question: examine the convergence of the series two minus 3 by 2 plus 4 by 3 minus 5 by 4 plus dot dot dot. Solution. Obviously this is alternating series. Okay, what is un? The first term, we can write the first term as 1 plus 1 by 1. Second term is, we can write 2 plus 1 by 2. Third term, we can write 3 plus 1 by 3. Fourth term, we can write 4 plus 1 by 4. Okay, so this is the pattern is n plus 1 by n. Yes or no? The pattern is n plus 1 by n. So we can write the series. The series is summation n equals to 1 to infinity. Obviously signs are alternately changed, so this will be minus 1 to the power n minus 1 into n plus 1 by n. Yes or no? So obviously this is our un, so un equals to n plus 1 by n. Okay, so this is our un. So what will be un plus 1? The next number. Okay, so this will be n plus 2 divided by n plus 1. Now first condition is we have to show that this is monotone decreasing. That means we have to calculate un minus un plus 1. This is equals to n plus 1 by n minus n plus 2 by n plus 1. So this is equals to, you are getting the LCM will be n into n plus 1. So this will be n plus 1 whole square minus n into n plus 2. So this is equals to, if I simplify this, so n square plus 2n plus 1 minus n square minus 2n. 2n 2n cancelled, n square cancelled. So you are getting this is equals to 1 by n into n plus 1. 1 by n into n plus 1. Okay, now tell me, this 1 by n into n plus 1, this is positive or negative? Just we have to show that this difference is positive. Yes or no? Now 1 by n into n plus 1, this is positive or negative? N is natural number. So obviously n into n plus 1, if n is positive, n natural number, that means positive. So n into n plus 1, so n plus 1 will be positive, n is positive, so the product will be positive. So this result is obviously greater than 0. Clear? So we can say that un, sequence un is monotone decreasing. Clear? The first condition is satisfied. Now second condition. Second condition is limit must be 0. So limit n tends to infinity un, this is equals to limit n tends to infinity n plus 1 divided by n. So this is equals to limit n tends to infinity, if I divide by n, so this will be 1 plus 1 by n. So the limit is 1 by n will be 0, so limit is 1. So obviously this is not equals to 0. Okay, and I have told you, if any one of the two conditions does not satisfy, then the alternating series will be oscillatory. Okay, so you can say, so the series is not convergent, not convergent, that is oscillatory. Clear? Very simple. Let's try another problem. Question: test the convergence of the series 1 by 2 cube minus 1 plus 2 divided by 3 cube plus 1 plus 2 plus 3 divided by 4 cube minus 1 plus 2 plus 3 plus 4 divided by 5 cube plus dot dot dot. Solution. So obviously this is alternating series, signs are alternatively changed. So find out un. What is un? First term containing one number, second term I am calculating the numerator. First term one number, second term two numbers, third term three numbers, fourth term four numbers. Okay, so what will be the n numbers, nth term? What will be the nth term? So obviously there will be n numbers, so 1 plus 2 plus 3 plus dot 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 plus n divided by, when n equals to 1, the denominator is 2 cube, n equals to 2, 3 cube, n equals to 3, 4 cube, n equals to 4, 5 cube. So n equals to n, n plus 1 cube. Clear? Now simplify. 1 plus 2 plus 3 plus dot 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 n. You have learnt in class 11, when APGP chapter you have learnt the sum of first n natural number, n into n plus 1 divided by 2. Yes or no? By n plus 1 whole cube. So if I simplify it, so your n plus 1 cancelled, so you are getting n by 2 into n plus 1 whole square. So this is your un. So what will be un plus 1? Just 1 increased, so n plus 1 divided by 2 into n plus 2 whole square. Okay, now we have to show that this is monotone decreasing. So un minus un plus 1. So this is equals to n by 2 into n plus 1 whole square minus n plus 1 by 2 into n plus 2 whole square. Just calculate this. Okay, half is common. Half. LCM is n plus 1 whole square into n plus 2 whole square. So we are getting n into n plus 2 whole square minus n plus 1 whole cube. So this is equals to half into n into, this will be n square plus 2 into 2, 4n plus 4 minus a plus b whole cube, a cube plus 3a square b plus 3ab square plus b cube divided by n plus 1 whole square into n plus 2 whole square. Okay, so now if I simplify this, un minus un plus 1, this is equals to half into, just multiply this, so this will be n cube plus 4n square plus 4n, n cube plus 4n square plus 4n minus this will be n cube minus 3n square minus 3n minus 1. Clear? Divided by n plus 1 whole square, n plus 2 whole square. So n cube cancelled, and so this is equals to half into 4n square minus 3n square, so n square, 4n minus 3n, so plus n minus 1 divided by n plus 1 whole square into n plus 2 whole square. Now this is the result. Now this result is positive or negative. The denominator is n plus 1 whole square. N plus 1 is positive and square of positive number is always positive. Similarly, n plus 2 whole square is positive. Half is always positive. Now n square plus n minus 1. If this is positive, then whole result will be positive. N square plus n minus 1. If this is negative, the whole result will be negative. So n square plus n minus 1. Is this negative? If I put the lowest value of n equals to 1, again the answer is 1 plus 1 minus 1, that means 1. So for the lowest value of n, you are getting the result positive. So obviously this result is positive, greater than 0. Okay, so we can say that sequence un is monotone decreasing. Clear? Now find out the limit. Limit n tends to infinity un means n by 2 into n plus 1 whole square. Okay, so this is equals to limit n tends to infinity. If I take common n from this factor, so this will be n by 2n square into 1 plus 1 by n whole square. So this is equals to limit n tends to infinity. Acha, so this is equals to 1 by 2n into 1 plus 1 by n whole square. So for this n, when n tends to infinity, the result will be 0. So obviously here both the conditions are satisfied. The sequence is monotone decreasing and the limit is 0. So hence by Leibniz test, the series is convergent. Clear? Now try your question bank and your previous year questions papers and also your textbook problems. Okay, if you have any query regarding this alternating series, you can ask me on comment section. Thank you so much.